So, if you remember, we were doing the theme probability distributions, right? So what is a probability distribution? Just refresh our memories. What's a probability distribution? Yep, absolutely. So it's a way of outlining the probability of particular outcomes, okay? And if you remember, I think the last lesson that we saw each other on the Friday, I think it was like 4 till 5 on the Friday, we started looking at a particular type of distribution. Can anybody remember the name of it? Binomial? Not binomial. We're going to do binomial today. We're using these, right? Uniform? Yeah, uniform distribution. Now, what's a uniform distribution? Can anybody remember? Absolutely right. So the probability of each outcome is always the same, okay? And the thing is, with probability distributions, sometimes the way to generate these things is just simply by doing the experiments, okay? But sometimes, if you know particular characteristics about the situation, then you can make predictions about what the probability is going to be, or what the probability of a particular outcome is going to be. Okay? So the uniform distribution, if you know that each outcome is equally likely, then you can work through the probability distribution from there. Now, the probability distribution that we're going to look at today is called the binomial distribution. Okay? So the binomial distribution. Now, I don't want to talk too much about this apart from the derivation of this word. Okay? So distribution we've already met, but what about binomial? What do you think the word binomial means? Any suggestions? Perfect. Yep. So you see this word here, the bi, think like bicycle, right? It just means two. Okay? And actually, does anybody know what the nomial bit means? No, if you've spoken French or if you've spoken Spanish, like nombre or nom, it just means named thing. Okay, so in this case, my named thing is just an outcome. Okay, so in this case, I'm looking at a situation which has two outcomes. Okay, like a coin, fantastic, because it's either heads or tails, right? Any other examples of binomial situations? A dice, go on. So on a dice, there's 6 outcomes, but I think we can think about it with 2 outcomes. How? Sorry? Odds and evens, exactly. Or sorry? Yeah, more than 3, less than 3, absolutely. So actually, I think every situation which has a probability associated with it can be thought of using binomial situations, because I can simplify it into either success or failure. So if I'm interested, for example, with a dice, at getting an odd number, if I get an odd number, I'm going to call that a success. Otherwise, I'm going to call that a failure, right? Another situation, for example, if I take that coin, it already has 2 outcomes, but I can also say, I'm only interested in getting a heads. That's my success, otherwise it's a failure, okay? You can think about it, for example, of people in here. I only want people over the age of 20. If you're over the age of 20, I'm going to call that a success, otherwise it's a failure. So pretty much every situation in life can be turned into a binomial situation, right? Either success or failure. Okay, so to illustrate this, I thought we could do a little activity. So I've defined myself on the board a random variable. That's my x, that's my random variable. And my random variable is going to be the number of times that a beanbag lands in the circle in a set of 5 throws. So literally what I'm going to do, and there's lots of excess around, I've tried to put 2 on each table, but if you want more, then feel free to take them. On each table, you will see that I've put this circle, okay? So a piece of paper with a circle in, right? And then I've also got a beanbag. Now what we're going to do in just a second is we're all going to stand up. We're all going to take about 2 steps backwards from the table. We're going to put the circle on the table, like so. And we step backwards, and all we're going to do is throw the beanbag and try and get it to land in the circle. Now you can see there, it missed, so I would classify that as a failure. And all I'm going to do, or all you're going to do, is throw it 5 times. You're going to have 5 attempts at throwing this beanbag, and you're going to count the number of times that that the beanbag lands in the circle. Okay? And then you just store that number, and then I'll put it on the board in just a second. Okay? So can we all stand up, please? Shushing, you good? Okay, fantastic. So hopefully you should have a number, and that number corresponds to the number of times that the beanbag landed in that circle. So hands up, who didn't get any in the circle? No one? Okay. How many people got one time landing in the circle? One success? No one. You're pretty good. Okay. What about 2 times? So 1, 2, 3, 4, 5 people. Cool. How many people got 3 times? Okay, 1, 2, 3, 4, 5, 6. Cool. How many people got 4? 5 times? Okay, so everybody's on there. Cool. Okay. So I want to improve the quality of this data. So stay standing. Stay standing. I want to improve the quality of this data. So how can I do this? Do it again. So another 5 throws. Okay, good. So how many people this time got it landing no times in the circle? They didn't get any successes. Okay, no one. Or maybe they did and they don't want to say. So how many people got it landing once? Yeah? How many people twice? So 1, 2, 3, 4, 5, 6, 7. Okay, so that's going to add us up to 12. How many people got it landing 3 times? 1, 2 people. Okay. How many people 4? Anybody 5? Yes. Oh, Mohanad. Okay, so let's do this one more time. Okay, let's improve our data even more. Let's do this one more time. Another 5 throws. So how many people didn't get any successes? Anybody get it no times landing in the circle? Okay, how many people got 1 success? Okay, so got 1 more person, so we got 2. How many people got 2 successes? 1, 2, 3 more people, so we got 15. How many people got 3 successes? 1, 2 more people, okay. How many people got 4 successes? 1, 2, 3, 4, okay. And how many people got 5 successes? Anybody got 5 times? No times this time. Okay, good. This beanbag throwing activity either results in a success or a failure. So in this case, what is our success? Exactly, it lands in the circle. And a failure is obviously it's not landing in the circle. Okay. So this here would be my probability distribution. Okay. Now what I really want to do at the moment, this is not probability. What is this instead? It's frequency, right? So at the moment, I just simply have a table of the number of times that each outcome occurred. Okay, so it's a frequency distribution. So how do I convert this into a probability distribution?
Line chart.
Sorry?
Line chart.
You could do a line chart, but I just want a probability here rather than the number of times it comes up, rather than a frequency. So how can I convert this into a probability?
You add all the outcomes, and then
Yep.
you divide each one of them with the total number.
Exactly. See how many times the beanbag was thrown in this room, like we did it all 3 times each, and there should be about sort of, I don't know, 10 of us in here. So hopefully this will come as a number close to 30. I know some people came in and out, right? And then divide each of these outcomes by the number of times it came up. So can I give you 2 minutes to convert this into a probability distribution for me? Okay, so I think some people have got it. If you're just finishing off, that is fine. Just make sure you agree with our numbers, okay? So what's the probability of getting no successes? 0, perfect. Okay, that's a nice and easy one. Let me do it in red. Okay. What's the probability of getting 1 success?
1/16.
Sorry? 1/18th? 1/16th, I think. 16th? No, it's 16, I think. Because it's 2 out of 32, or 1/16th. Yeah? Did we get it as a percentage?
Yeah, 6.25.
6.525 or 6.25? 6.25%, cool. What's the probability that 2 outcomes are successes? 46.9%? Yes? Yeah? 6.75 for 3 successes?
5 rounded to 9.
Sorry?
31.
31. 31.25%. Okay, what's the probability of 4 successes? 12.5%. Probability of 5 successes? 125. Okay. Okay, cool. Okay, let me just put some dividers in to make this a little bit clearer. Okay, so this now, I think, is a probability distribution. So in other words, if you wanted to keep throwing this beanbag over and over and over again, what you should expect is approximately 47% of those outcomes should result in a 2, okay? 31 should result in 3 successes. 12.5% of the time you should get 4 successes. 3% of the time you should get 5, and about 6% of the time you should get 1.